To report upon our learning of the functionality of suspension bridges, brainstorm and identify possible challenges associated with the construction of suspension bridges, and determine solutions to these challenges.
Mats are necessary to provide friction for the base of the suspension bridge. With the static friction force, the base will be stable and won't move around when live load runs across.
Positions can be established with the use of electronic distance measurement machines, such as Sokia Total Station and the Global Positioning System. Other methods include the use of an automatic level or taping. EDM would have the highest accuracy, whereas automatic level would have the lower accuracy. Taping can be expected to have the lowest accuracy, especially considering it would be difficult to tape across a body of water.
Establish the foundation on both sides of the lake. Build the towers at the end of the foundation, attach the chain to one side of the foundation, and use a boat to transport it across the lake to the other side. Attach the slabs to the chain and ensure the slabs are supported by a truss below the slabs, and ensure each slab is interlocking with the one before. Continue the process to the end of the foundation.
A sturdy pilot line is strained and put into place first using a helicopter or carried to the desired location by boat and then lifted by a helicopter. After the pilot line is fixed in place, the main cable can be attached to one end and moved across by motors.
The external forces working on a suspension bridge includes static load, weight of the bridge itself, dynamic load, traffic on top of the bridge, and environmental factors such as precipitation, temperature, wind, and possible natural disasters. Internal forces have tension, which is the cables and suspenders, compression, result of gravity, torsion, a possible twisting force, and shear, a possible push or pull force in opposite directions.
These loads are transferred from one member of the bridge to the two beside it, creating a long chain of support forces that ends at the two towers. As any sort of load acts on a member of the bridge, the member itself is supported by the two members beside it. That means that a load is gradually carried from the member to the two towers. This also means that if the connection between two members is not strong enough, the bridge falls apart as the connection is severed.
Tension equals mass of supported deck times gravity, and the ratio between the supported deck to two main cables would be 1 to 1. But if you look at an individual cable, it will be 1 to 2. The reason for this is because the weight of the supported deck goes directly to the cable.
The foundation moves. The force generated by the truck causes a slight moment as the truck is on the right side of the bridge, causing a moment in the clockwise direction.
By having a longer deck, the point load on the bridge can be distributed over a larger area. The force would be spread out to the surrounding columns and cables. In comparison, when the surfaces are smaller, the support from cable wouldn't be able to properly carry the point forces and would cause the deck to lift at one side and produce a rotational moment.